MANET security through a distributed policy-based evaluation of node behaviors by Alice Hunda. This is a course project. Mobile ad hoc network is infrastructureless design where different nodes are connected through wireless. It faces the different problem of security due to the following fact. It is dynamic and its topology is not stable, and also it doesn't have any central device in charge of security control, and it is open where other devices can get connection, even those which are not trusted, and different nodes can join this connection, which can cause the malicious to attack this network. In addition to stated vulnerability of MANET, communication and addition of new nodes is also a big problem. For the trust value is a value which is obtained from the collection of flexible policy rules. One example of a policy rule is that when a node is directly connected to another, they might fully trust each other. This is another challenge, because even if they are neighbors, doesn't mean that they are secure. It is not enough for the nodes to trust each other. That's why it's better to know the behavior of each and every node. However, it can be so expensive for every node to have information of other nodes. For example, in charge of memory, energy, and so on. That's why for the MANET, nodes have the information regarding to their direct connected nodes, which are called neighbors. The lack of this information lead MANET to be vulnerable, and also it can be facing other attacks. One of the most known attacks for the MANET is wormhole, which we'll be discussing for the next part. One of the MANET attack is called wormhole tunnel. It joins colluding nodes which basically are located far from each other so that they can communicate in secrecy. The wormhole tunnel distance is greater than the normal distance which was between two nodes. And sometimes one wormhole head is far from the normal neighborhood nodes, which is called out-of-band channel. For this channel is used to launch the wormhole attacks and get information from the network. Different systems and framework have been proposed in order to take care of MANET security. One of them is called trust-based system. Within this system, nodes trust each other, and they can update their path information based on information from other nodes. And it evaluates the trust values for each node. To produce this trust value, it analyzes the direct and indirect observation. It means that there are some nodes which are directly connected to the destination, and there are others which require intermediate nodes to help them to reach out to the destination. The direct and indirect observation made up what we call belief value, and this belief value is used to detect if the node is malicious or not. Even if trust-based system was for protecting the MANET against attack, it has different weaknesses. It is open to every node, regardless where the node is located. It means that no matter how far the node is located, it can ask their request to be connected to MANET network and get that access. The flexible policy rules, which are based on to decide if the node is malicious or not, are sort of relating to all nodes. It doesn't consider the node behavior, and it is not robust. in charge of the security of MANET, it didn't specify clearly the mechanism to secure MANET. Hence, it needs further studies to establish how the security will be made into function. After realizing that MANET is still facing some problem of security, different researchers proposed other approaches. Now we are going to discuss about policy-based approach. This framework requires each and every node to check its behavior in order to reveal any anomaly. The anomalies are revealed based on the expected behavior of a node. Behaviors can be different based on the type of the malicious which they can face. For this approach, the test has been done on the wormhole attack. It is based on 3 classifications of nodes. One approach is for the least attached neighbors, another is for the most absorbing neighbors, another is for the further neighbors. We are going to discuss about these 3 types of nodes and how can we reveal that there are some malicious or not. Least attached neighbors. Within this approach, we consider the radius between 2 nodes in transmission range. For example, here node 8 and 4, the distance between them is bigger than the distance between 8 and 6 and 8 to 9. When you have nodes which are not spread too much into the transmission range, node neighbors can be neighbors of each other. For example, 6 is a neighbor of 8 and 6 is a neighbor of 9 as well. But comparing to 4, 4 is so far from these neighbors. It means that node 8 and 4 will finally form a tunnel and the malicious will come from 4 to 8 and be spread into other nodes. Because node 4 was considered as out of band channel, it is so far from other nodes. To detect malicious, we might also compare the distance between nodes. Most absorbent neighbors. The malicious node is targeting always the node with much information, and it can use the tunnel created to reach out to other nodes. For example, here node 4 is targeting to node 8, and after reaching to node 8, it will spread its malicious to 2 to 5 to 10 and 11. We can detect the malicious based on which node is willing to be connected to. If we know that this node is the most important node in our network, we can start to track the node which is willing to be connected to the most valuable node. The last approach is called farthest neighbors. Within this approach, it has been seen that malicious nodes are spread far from other nodes. We can send the hello message which is time stamped and calculate the time which will be taken to reply to this message. If the reply are coming so late, those nodes can be tracked and be analyzed to see if they are really the malicious nodes. Different simulations have been implemented on different sizes of MANET networks. For example, here we have 40 nodes where they launched the one wormhole, and another was composed by 60 nodes and they launched the 2 wormhole. Here on the graph we can see the results, and for example, if we take this purple color where shows 2 wormhole without framework, and the blue color with 2 wormhole with framework, we can see the big difference. It shows that by using the framework, which is the blue color, even if there were 2 wormholes, the framework managed to remove those wormholes and reduce the delay. As conclusion, no single node can have all the information about other nodes. That's why for this study they used partial knowledge. However, success rate is almost 82 for 40 nodes and 78% for 60 nodes, which is the best success. We can conclude that policy-based evaluation is an improvement of trust-based system because it managed to detect and react to wormhole. It has also a way of distributing its techniques based on different approaches and can reveal malicious node in MANET. Policy-based evaluation is also scalable and robust. However, there are other limitations for this study. It is shown only for one type of attack, which is called wormhole, and it is known that MANET faces other type of attack. It used a limited number of nodes compared to real-life cases. And also it considered only one type of protocol, which is called on-demand distance vector, where MANET used other protocols such as cluster-based route protocol and so on. As a recommendation, for further study, experiment can be tested on a large number of nodes and also can consider different types of attack. We propose that the secured ad hoc on-demand distance vector, which is in charge of the security for MANET, can be used to see how the system will react to the attacks. And also we can consider the cluster-based routing protocol in order to avoid congestion. Thank you.